Is bridge. Bridge is a networking device which is used to divide a LAN into multiple segments. Bridge works under data link layer of OSI model. Bridge stores the MAC address of PCs available in a network. Bridge is used to reduce the network traffic. Let's take a live example for better understanding. Bridge basically used in a bus topology. In bus topology, the time PC1 tries to send data to PC8, the data is used to broadcast to all the available PCs in a network. And like this, it simply creates a lot of traffic. So, from overcoming this problem, we are using a networking device called bridge. Bridge divides a LAN into two segments and stores all the PC's MAC address into its table. Now, if the PC1 tries to send data to PC2, the data will first travel to bridge. Bridge will read its MAC address table and decide whether to send the data to segment 1 or segment 2, and after that it will broadcast. Hence, the PC2 is in segment 1, so the bridge will only broadcast the data to segment 1, and like this it reduces the traffic in a network. Let's take another example. Here PC1 is trying to send data to PC8. So the data will first travel to bridge. Bridge is going to read its MAC address table and decide whether to send the data into segment 1 or segment 2. Hence the PC8 is in segment 2. Bridge will broadcast its data in segment 2. So guys, hope this video is helpful for you. Then please hit the like button. Here is a small test for you guys. What is gateway? How any device in a network acts as a gateway? Difference between gateway and router with live example. This video on difference between hub, switch and router is running pretty well on my YouTube channel and my viewers are loving watching that. I will highly recommend you to watch that video for better understanding. So guys, let's start with what is gateway. Gateway is a networking device that connects two networks using different protocols together. It also acts as a gate between two different networks. It may be your router, firewall, server or other devices that enables traffic to flow in and out of the network. Let's take a live example for better understanding. In this scenario, server is sending data to PC1. This data will first get entered into this switch. After that, it will reach to PC1. Same like this, PC2 is sending data to PC3 and PC4 is sending data to PC5. And all this data travels through the centralized device switch. Like this, switch is acting as a gateway that enables traffic to flow in and out of the network. Let's take another example. Here, network 1 is assigned with the IP address 10.0.0.1 with the CIDR value 8 and network 2 is assigned with the IP address 20.0.0.1 with the CIDR value 8. As these two are different networks, it cannot communicate with each other. So we use a centralized device called router. Now, whatever data is sent by network 1 into network 2 or vice versa, it will go through the centralized device router. Like this, here router is acting as a gateway. It is the main gate to enter into different networks. Now here is the most complicated and confusing question. You might have searched in internet too. If this device can act as a gateway, then what is the use of gateway device in a network? Let's take an example. Router can communicate between two different networks using the same protocol. On the other hand, Gateway is used to communicate between two different networks using different protocol. For this reason, gateway is also called protocol converter. Here are the few differences between router and gateway. You can go through this.
What is an access point? In a wireless local area network, WLAN, an access point is a station that transmits and receives data. An access point connects users to other users within the network and also can serve as the point of interconnection between the WLAN and a fixed wire network. Each access point can serve multiple users within a defined network area. As people move beyond the range of one access point, they are automatically handed over to the next one. A small WLAN may only require a single access point. The number required increases as a function of the number of network users and the physical size of the network. A wireless access point can also be used in the so-called ad hoc mode as a central interference between multiple devices. This allows devices such as computers and printers to be connected wirelessly. Wireless access points mainly perform the same tasks as bridges and switches. They connect between devices at a hardware level. On one hand, they avoid data collisions through techniques such as CSMA, meaning Carrier Sense Multiple Access, or CA, and on the other hand, bridges differences between different transmission media. In the OSI model, or wireless devices points such as switches and bridges in the data link layer 2 settled. By comparison, the well-known protocol Ethernet also covers the data link layer, but also the underlying physical layer, layer 1. WLAN routers are composite devices from a router with integrate wireless access point. These devices also address higher layers of the model by providing features such as routing, packet filtering, and DHCP server. An IEEE 802.11 wireless network is assigned a wireless network name ESSID, which is Extended Service Set Identification. The SSID allows clients to distinguish between networks. An access point can now regularly send data packets with the ESSID via broadcast telegram so that the clients can identify an existing network. A key differentiator of 802.11 base stations is their operating modes. Some access points can connect to other access points and clients at the same time. The NAPs were a key component in the transition from the 1990s NSFNet era to the commercial internet providers of today. What is a repeater? Network repeaters receive and retransmit incoming electrical, wireless, or optical signals. With physical media like Ethernet or Wi-Fi, meaning wireless fidelity, data transmissions can only span a limited distance before the quality of the signal degrades. Repeaters attempt to preserve signal integrity and extend the distance over which data can safely travel. A repeater is a small device that plugs directly into a power outlet. Positioning the repeater in the right location is important. Locate the repeater where the Wi-Fi signal is strong. A location halfway between the router and the weakest reception area is ideal. Then, following instructions that come with your repeater, log into the Wi-Fi repeater on your computer and enter the login information and password of your Wi-Fi network. The repeater connects to the Wi-Fi network and boosts the signal strength from its location outward. Some range extenders boost the signal equally in all directions, but if your repeater has antennas, you can direct them towards the areas of weakest reception. Tips: before you install your repeater, use an online speed test in an area of poor reception. Then rerun the test after you install the repeater to see the speed improvement that repeater gives you. Advantages of a repeater: simple to connect, cost effective, ability to strengthen signal. Disadvantages of a repeater: repeaters provide no method for isolating traffic generated on one cable segment from traffic generated by the other cable segment. When network uses a repeater to connect cable segment A to cable segment B, whether or not there is a station in segment B, that is the destination of the signal.
What is a modem? Modem, modulator and demodulator. Modulation is changing the digital data from a computer to analog data to be sent over telephone lines. Demodulation is changing the analog data which is received over the telephone lines to digital data to be used by the computer. A modem is a network hardware device that modulates one or more carrier wave signals to encode digital information for transmission and demodulates signals to decode the transmitted information. The goal is to produce a signal that can be transmitted easily and decoded to reproduce the original digital data. Modems can be used with any means of transmitting analog signals from light-emitting diodes to radio. A common type of modem is one that turns the digital data of a computer into modulated electric signal for transmission over telephone lines and demodulated by another modem at the receiver side to recover the digital data. Modems are generally classified by the maximum amount of data they can send in a given unit of time, usually expressed in bits per second, symbol BITS, sometimes abbreviated as BPS, or bytes per second, symbol capital BS. Modems can also be classified by their symbol rate, measured in baud. The baud unit denotes symbol per second or the number of times per second the modem sends a new signal. For example, the International Telecommunication Union ITU V.21 standard used audio frequency shift keying with two possible frequencies, corresponding to two distinct symbols to carry 300 bits per second using 300 baud. By contrast, the original ITU V.22 standard, which could transmit and receive four distinct symbols, transmitted 1200 bits by sending 600 symbols per second using phase shift keying. Many modems are used to connect to the internet through telephone service or cable television service. Slow telephone service is called dial-up. Faster telephone service is called DSL, digital subscriber line, and is usually more than 10 times faster. Thank you.